Today we're going to be talking about finite arithmetic and geometric sequences. We talked about some arithmetic sequences yesterday and some neither types of sequences. Today we're going to talk about shortcuts for arithmetic and for geometric. So remember, an arithmetic series is formed by adding the terms of an arithmetic sequence. And what we can do is we can use this formula right here to figure out the sum. So the sum of the nth term, or the n terms you're adding up, is going to be n times ace of 1 plus ace of 2 divided by 2. We type that in the calculator and we will get our sum. Remember, ace of 1 is the first term, so okay, s of n is the sum of the first and last terms multiplied by the number of terms, n. Now, to figure out the number of terms, you want to subtract the top limit and the bottom limit and then add 1. So this makes much more sense when you look at these examples. So we need 3 components. This is an arithmetic sequence, so we need 3 things: n, ace of 1, and ace of n. Well, ace of 1 is going to be 9 plus 3 times 1, or 12. Then ace of 15 is going to be 9 plus 3 times 15, which that is going to equal 54. N is going to be the upper limit, 15, minus the lower limit, 1, plus 1. Now, I know you're thinking, well, if we're going to minus 1 and add 1, why do we do this? What if our bottom limit is not 1 and something different? Then we have this other process. So this is going to be 15. So then our formula, S of 15, is going to be n, which is 15, and in parentheses, 12 plus 54 divided by 2. Now, if your calculator can't do fractions, then you will want to add 12 and 54 first. But if it can add fractions, we can do 15, parentheses, fraction, 12 plus 54 over 2, close parentheses, and it's 495. So that's far quicker than having to go through and find the first term, the second term, third term, all the way up to 15, and then adding them together. This one, we want to calculate our ace of 1, or sorry, not ace of 1, ace of 3, and that's going to equal 7, that's going to equal 77 minus 4 times 3, and that equals 65. Ace of 18 is going to be 77 minus 4 times 18, and that equals 5. Now for our n value, that's going to be 18 minus 3 plus 1, which is going to be 16. So now I'm going to do S of these 16 terms is going to be 16, and then 65 plus 5 over 2. And I'll show you how to type that in the calculator again. So 16 parentheses 65 plus 5 over 2. And that gives us 560. So that formula was a nice shortcut to get these sums. Now, a geometric series, that's the expression formed by adding terms of a geometric sequence. And just like with the arithmetic sequences, we do have a formula to calculate the sum for geometric sequences. And what you need is your ace of 1, which you can get from the explicit formula pretty easily, and your R value, that rate, which again easily comes from the explicit formula. N is still going to be, this N right here is still going to be that upper limit minus the lower limit plus 1. So let's look at these down here. All right, so ace of 1, that's 3. Your R value is 4. And then your N value is going to be 13 minus 1 plus 1, which is 13. Then S of 13 is going to be ace of 1, which is 3, and then parentheses 1 minus R, which is 4, raised to the nth power, which is 13, divided by 1 minus 4. And I'm going to type that in the calculator. So 3 parentheses, and we have a fraction, 1 minus 4 raised to the 13th power over 1 minus 4. Make sure you press the over arrow, close your parenthesis, and you get a big number. When you're doing sums of geometric sequences, you are going to get a large number most of the time because your value keeps growing and then you're adding to that. And you want to remember that geometric sequences kind of mirror exponential functions, and those exponential functions were functions that grew large very quickly. So it should make sense that this is a large value. So that would be your sum. All right, so then with this one, our ace of 1 is 7. The R value is -5, and that's okay. N is going to be 11 minus 1 plus 1, which is 11. Now, when we write this sum formula, the sum of the 11 terms, remember there's a minus sign. It's minus R, but R is already negative. So you want to make sure you account for that. So 7, parentheses 1, minus -5 raised to the 11th power over 1 minus -5. So in the calculator, 7, and then in parentheses, 1 minus -5, negative raised to the 11th power. I didn't make a fraction. Let me do 7 parentheses fraction 1 minus -5 raised to the 11th power over 1 minus -5. If you know that this is just going to be like 1 minus -5 is going to be 6, and you want to type it as 6, you can do that. So now we get that as our sum, that honkin' big number. So this is going to be 56966 147. So I want you to be able to use this formula and practice that. Right, find the sum of this geometric series. Now, look at, we're starting at 0. Our formula, though, always starts with that first term. Since we're starting at 0, we actually need to find what s of 0 is. So 2 times 3 over 2 raised to the 0 minus 1 power. We can calculate that. 2, and then in parentheses, 3 divided by 2 raised to the negative 1 power. We get 1.33. It says round your answers to 4 decimal places, and you could go that precise at the, if right now if you want, but I'm going to wait for the very end. So now I can use get my n value, where it's actually going to be 8 because 7 minus 0 plus 1 is 8. So s of these 8 terms, that's going to be s of 0, the first term, 1.33, times 1 minus the rate, which is 3 over 2, raised to the nth power, which is 8, over 1 minus 3 over 2. So this looks incredibly ugly, but we can still do it. 1.33, parentheses, a fraction, 1 minus another fraction, 3 over 2 raised to the 8th power over 1 minus 3, 3 over 2. We get 65.51. Right now, on the next page here, we have some word problems. So in 1990, the total box office revenue at U.S. movie theaters was about $5.02 billion. From 1990 through 2003, the total box office revenue increased by about 5.9% per year. What this tells us, this increasing by 5.9% per year, this tells us this is an exponential model, which means we are dealing with a geometric sequence. And the formula for geometric sequence is a sub n equals a sub 1 times r raised to the n minus 1 power. Well, here is a sub 1. Now the r value, r is going to be 1 plus 5.9%. 5.9% in decimal is 0.059. So 1.059 is my r value. A is saying write a rule for the total box office revenue in terms of the year. So our rule, a sub n equals 5.02 times 1.059 raised to the n minus 1 power. So that is our rule. Letter B is saying what was the total box office revenue at the U.S. movie theaters for the entire period from 1990 to 2003. So we have our a sub 1 and our n value, the r value from the original problem. We need to figure out what n is. N is going to be 2003 minus 1990 plus 1, and that's going to be 14. So the sum of these 14 years is going to be 5.02, that's a sub 1, times 1 minus 1.059 raised to the 14th power over 1 minus 1.059. So we're going to type that into our calculator. Alpha y equals 1 minus 1.059 raised to the 14th power over 1 minus 1.059. Oops. And then we can close our parentheses. Oops, that tangent. And we get 104.76 billion of dollars. All right, one day you saw an awesome video on YouTube. At 1 p.m. you shared the link with 5 people. So that's my first term. Ace of 1 is 5. And then you at 2 p.m. each of your 5 friends shared it with 5 other people. Then at 3 p.m. each of their friends shared it with 5 other people. So I go from 5 to 25 people having the link to 125 people having the link. So the R value is also 5. Okay, so now I have the A value, I have the R value, I need N. So I go from 1 p.m. to 11 p.m. So my upper limit would be 11, minus 1 plus 1 would be 11. So now I can use that formula. S of 11 equals 5, and then parentheses 1 minus 5 raised to the 11th power over 1 minus 5. And again, we will type that into our calculator. Oops. Five, and then parentheses 1 minus 5 raised to the 11th power over 1 minus 5. And we get that large number. That's how many people have had the link after those 11 hours. 6103. 5155. So that's the power of exponential growth. We started with 5 people with the link, and then it got that up to 61 million in only 11 hours, just by 5 people sharing with 5 others, and then those people sharing with 5 others, and so on. So that's it for these sequences. Thanks for watching the video. Make sure to like it and subscribe.